Hello guys, so in this video we are going to check constant function. In the last video I showed you identity function. Now I'll show you constant function. Then we will see we can combine a continuous identity function and a continuous constant function, and when we add them or subtract them, that will also be a continuous function. So let's start. Graph of some function. Same thing like last one. We will check the function, its graph and its continuity. So the second function will be constant function. If you have not checked my previous videos, please go to the description and check the links. From there, whichever video you want to check out, and I will be bringing in identity function concept also, so please watch that video and then watch this. So what is a constant function? What do you mean by constant? Constant means something which does not change. Which does not change, right? So it is a function in which no matter what value you put, the outcome will never change. Suppose I am writing f of x is equals to 5. Okay, now from real number line, which is the domain, you take any value for x, but the answer will remain 5 because it is a constant function, it will not change. Clear? So this will be your range. Okay, what will be my codomain? Codomain will be real number line, bigger set. Okay, range is only the connected. So all the elements here, if you are putting, no matter how many elements you put here, all will be connected to 5. So this is the only range I have. Clear? Now let's start with the definition. Now function f defined from the domain R to the codomain R such that f of x takes a constant value c for all x, for any x you take which belongs to your domain, that is real number line. That is called a constant function. Clear? So for any constant function, fx is equals to c. You can have any value here. For all x belonging to R we have. Okay, so understand this definition. Now you see, for the constant function, this has to be true always. Fx equals to c for any x you take from your domain. Okay, so here what is your domain, which is this R, and range as I told you will be only one element, that is c. Clear? So if let's see an example on this so that you will understand better. Now this, you can see fx equals to 2, right? This is acting as c. It will never change whatever x value you put. Some more examples. Fx equals to 0, fx equals to -2. So these will be your constant functions. So now let's see one of the examples. So we will be seeing the graph of fx equals to 2. So what is the solution? By solution I mean that I don't even need to make the table like this. X fx I will make, but whatever x value you put here, you will get 2 only. 1, you will get 2, 2 value 2, 3, you take 2, you'll get like this. So see the table which I made. So you take minus 2, you'll get 2. You take minus 1, you get 2. You take 0, you get 2. You take 1, you get 2. Take 2, you're getting also 2. So no matter what value you take, the function result will not change. Okay, so this is graph of fx equals to 2, which is this. Okay, so you can see, if I let's see the scaling first. What is the scaling? On x-axis, 5 small division is 1. So 1, 2, 3, 4, 5. This is 1. This is 2. This is 3. This is 4 here. This is 4. Similarly, this is 1. On y-axis, 5 small division is equals to 1 unit. So this is 1. And this is 2. And here this is 3. Clear? So I will not write negative sides because I don't need them. Okay, I need the negative side of x-axis, so I will write it minus 1, minus 2. I don't need minus 3. You can see the table. Okay, so for minus 2 the value is 2. For minus 1 the value is 2. For 0 the value is 2. For 1 the value is 2. For 2 the value is 2. So you will have a straight line which is parallel to the x-axis. Okay, so you can see this kind of graph will be formed for a constant function. If you look at these, you will know that the line, the equation of this function will pass from here. This will be the line. Okay, for this you can see fx equals to minus 2. That means it will pass from minus 2 here. As a line will pass like this. Clear? So you can draw the graphs for other functions yourself. And what can you say about the continuity of this function, whether it is continuous or not? Yes, this function is continuous because you can see there is no value in your real number which will be not defined, because everyone will have a value 2. Clear? So everywhere on R you will have some value that is 2. So it will be defined everywhere, so it is continuous. Okay, so by looking at the graph also you can say it is continuous. Clear? Now let's see, if I have x plus 2, this is my function now. Okay, so this function I already told you, if I separate them, this will be what function? Identity function. This is identity function and this is constant function. Okay, so if this is identity function, this part is for class 12. 11 also can hear it. So this is an identity function. So tell me whether identity function is continuous or not. Yes, it is continuous at any point. At any point it is continuous. And constant function, whether it is continuous or not, we just saw that constant function is continuous at any point. At any point. So if I combine them while doing continuity video, see continuity video. So while doing continuity video, I told you that if fx and gx are two continuous functions, then fx plus gx is also continuous, right? So see, if this is a continuous function, this is a continuous function, I add them up, I get a continuous function. Okay, so we are done with two functions, identity and constant function, and we saw that if I combine them I will get a continuous function again. So next I'll be bringing another function. Thank you.